Hey guys, WantClue here. It's fantastic to have you back. In today's Bitaxe 101 episode, we want to take a look on how to repair a Bitaxe and make it functional again. The ASIC chip is broken and you want to know how to solder? Let's get into it. So guys, it literally has been a really long time since I showed you how to solder and how to do a couple of things. So this right here is a broken ASIC and you can see that. Do you see this crack in here in the middle? So the ASIC itself literally is cracked. And what we want to do is we want to remove that. And I do have a package of some fresh new ASICs. So we want to solder one of them onto it. Let's grab the hot gun and let's remove this chip. I simply use my hot gun here and we're gonna heat up this section all around the ASIC. Then we need to take a look on if we need to clean it, apply new solder paste or not, depending on how much is left on the PCB, and then we can just attach a brand new chip one. Maybe we need to do a little bit of soldering on the new chip, we will see. So let's quickly heat this section here up. This takes a little bit of time, so it's a convenient process if you want to spend a little bit of time. I usually fly around all around the chip and I try my best to give you guys a good view of how to do this properly. So I fly around the chip itself a little bit to spread the heat as good as possible to make sure that everything is working smooth. Oh man, the cable itself is a problem. Maybe I need to put my station somewhere else. So I'm running this at 380 degrees Celsius and so far it's not heated up enough. So this would take a little bit longer. Even if we now do anything bad to this section, it's not that bad because the chip is already broken. So that is not really an issue. Only thing you want to make sure is that you do not burn yourself. I did this multiple times. It is a mess. Let's see. No, the chip is still not coming off, so we need to heat it a little bit longer. It really takes a little bit of time. It's a tedious process. The PCB needs to be heated, the chip needs to be heated. Everything just takes a little bit of time, and I fly sometimes to the left, sometimes to the right, just a little bit all around it. It really takes some time. And here we go. Chip has been removed. So let's quickly put my heat gun to the side so that I do not burn myself, and let's wait for the PCB to cool down. So what do I have here? I have a whole package of new chips. They got sent to me over from a friend of mine here in Germany. I mean, they are used. You can clearly see that. Yeah, here we go. So these chips are used, but they don't have any sort of cracks. So now I need to take a look on the PCB. The PCB itself does have a little bit of solder everywhere around, and there's also a fraction of solder on the chip itself. But we could do two things. One thing would be to use the solder paste that is already on there, which I don't really prefer. And the second one would be to clean it up with a wick. This here is a desoldering wick, and with that it will take all the junk that is on there, and I think that might be the best idea to do. So first thing first that I do is I will apply a little bit of flux. Flux is a magic component that actually helps with putting solder on the right spot. Let's just apply a little bit of flux everywhere. Now we need our soldering iron. I do have this mobile one here, which is pretty handy, as well as a welding head cleaning copper thingy here. So let me quickly grab my charging cable for this one and then we can move along. Plug this in. Okay, let's heat it up. It gets to like 400 degrees, which is fine. I grab myself these magnifying glasses here so that I do see a little bit better. So what I'm gonna do is I take the desoldering wick and I just go over the area here. Try to grab as much of the solder as possible, especially on the pins. Like, you want to make sure that these pins are as clean as possible. We probably need a little bit more flux. So let's quickly put this to the side, add a little bit more flux to it. I mean, there's a little bit of flux on the desoldering rig in it, which is helping, but adding more flux make it just easier for me to do the desoldering. And obviously the best thing would be lock it in a place, you know, like having a third arm. I do have a third arm, but I'm just a little bit of, all right, let's fuck around and do that here. This now looks more or less clean. There's a little bit left here, and now everything should be clean. I hope you do get the impression of how to do this. The next thing that I'm gonna do is I do have some isopropyl alcohol here. I put that on it. I also do have an old toothbrush, which I usually use for these things, and then just any sort of cloth, usually some tissues or whatever. I do use them. So let's power off my heat gun or my soldering iron, that I do not burn myself here. Then we can clean up the chip here. So we just put a little bit of isopropyl alcohol on it, and we scrub around a little bit to clean off all that flux off of it, and now with a cloth we can clean it. The best part about this is you can feel if you did it right or not, because if you did it wrong, you would notice this on your cloth that you do have, because then it would stick to it or it would get ruptured or anything. So if you did everything correct, then it should just go smoothly over it. Obviously it's a little bit rough here, but the next part that we're gonna do here is we're gonna apply, I should have a stencil for it, which I can put above it, and then apply a little bit of solder paste to it so that we can perfectly solder this together. Okay, here we go. A couple of things have changed. There's a stencil on it. If you don't know what a stencil is or how you can get yourself one, check out the info card up here, because I just recently made a video about how you can create and order yourself your own stencil. Obviously, creating a stencil for a specific size can be done differently. I did it the way that I did it. Simple, not really needed in the way that I did it there, but it's totally working. And if you're interested in that, just check out the video up here in the info card. Anyway, what I haven't showed you is I do have this solder paste right here. This basically is just some paste, and I already applied the stencil. So I just put it on here, made sure it does align perfectly from the holes to the pins on the board. So here we go. So the holes are perfectly aligning with the pins on the board. Now what I'm doing, I'm taking this tiny tool here, which is really flat on the front, and I will just use a little bit of solder paste, scrub it over it, and then remove the stencil. Check out if the solder paste is properly on the PCB, and if it is the case, we can solder the ASICs. These are BC chips. I was originally thinking about using them, but I want to try something, and I got myself PM chips. They are on top with copper. If I'm not mistaken, they are usually used in hydro miners because they can be used to remove the heat a little bit better off of them. I believe that is where they are used. They should be brand new, or at least close to. They do not have any sort of solder on them. They have never seen solder. They are clean, really clean. Golden here on this side, also coppery golden-ish on this side. So that's the idea here that we do have. Let me now apply a little bit of solder paste. You just usually need a tiny amount, not that much. So you see, it's not really that much. I had a holder for a Bitaxe. I don't know where it is. I probably got rid of it because it janked up over the time. I should try to find the holder, or at least post you the holder in the video description, because then you can just place your Bitaxe in the holder and you can firmly align things. So with that, now I need to press down on the stencil on this side because I'm only having it firmly attached with this tape here on the right hand side, not on the left hand side. So I press down here, I just go over it, and with some firm scratches I should be able to apply the solder paste evenly, hopefully. Alright, so let's clean up the tool. Now I'm gonna use myself some tweezers to remove the stencil. So let me lift up the stencil firmly, and let's see if that worked. It didn't. I was using way too much. So what we can clearly see here, I'm trying to align you, camera. So we do have too much paste on this side and a little bit less on that side. So there's too much over there. What we need to do now, and it's good that it's happening, is we need to get ourselves, I don't know, some cleaning cloth or just some Tempos, just clean it. Also clean up the stencil itself, because you want to make sure that the stencil itself is also clean. Cleaning the bottom side of it as well again. Usually you could use some isopropyl alcohol. Sometimes I do that, sometimes I don't. And now we just repeat. Here we go. The stencil itself is not clean how I like it, so I use some old toothbrush. I go over it a little bit. Then you can just lift it firmly again, use your cleaning cloth again, and remove whatever solder paste is on there. So now I take a look on my magnifying glasses here again, and now we repeat the process again. I'm pressing firmly down on this side. I just scrubbed over it once now, because I want to see if there's a difference while doing it that way. Let me lift up stencil, and that looks beautiful. That looks exactly the way how we want it to look. Perfect. All right, so now we quickly clean up our tool. That's always a good approach. If you do have any tools, always clean them immediately after use. So next thing is use a little bit of isopropyl alcohol. I put it on here, just a tiny drop. Use the toothbrush and I just try to clean it from both sides. And now with having that done, you can clearly view through that. So yeah, it's clean here. So the paste is on here perfectly. If I double check on that, yeah, everything looks okay. Now what we can do is we can take the ASIC chip, align it properly on there, and try our best with soldering it. I think I explained this previously in another video already. So on this one, we do have a tiny dot on the top left corner, which needs to be aligned with the dot that we do have on the board. Here, there's a tiny dot, and we need to align that perfectly. So this is the tricky part. You need to get your ASIC and you need to make sure it is aligned perfectly next to it. What I could do in order to achieve that is I can use maybe some fans or something to hold it in air. And this right here is the boring part. You need to be as close as possible to everything on this board. So there's the dot on the top left, obviously. You need to align both dots. And then there are tiny lines. And what you want to make sure is you want to align the ASIC chip itself exactly with these lines. And a good approach is to get really comfortable, chill, relax. It's a process that takes time, and it's a process where having shaky hands or anything else can be an issue. Let me quickly check out. I think there's a tiny piece of solder paste missing. It might be an issue. Let me try to fix that. Maybe that should work. I just tried that way. I mean, you can always remove it and reapply it, redo it all over again until your ASIC breaks or until you fucked up something else. So here we go. I'm trying my best. I think that's okay. I think we got it. All right, so now you need to be very careful with everything else. You don't want this to fall off or anything else. And I don't know, maybe these plastic thingies will melt now because now we need to use our hot air gun. I currently do have it at 390 degrees. It's heating up right now. And this will take a little bit of time. Especially the soldering part of it will take a little bit of time because you want to make sure that everything is properly soldered together. I tried again with my magnifying glasses also. Let me reduce the air pressure here a little bit so the ASIC is not floating away. And now this process is a little bit tough to actually show you if I'm recording from on top. But yeah, what I'm doing is I'm just hovering over it with the hot air gun. I'm trying my best of having a distance of like ½ centimeter. So I think that's a really good distance to have between the ASIC itself and a hot air gun. And then I'm just making circles around it and hoping that at some point everything will melt, everything will align together. So what's really interesting to me, it is freaking changing its color, this PM chip. It is really wild. So we had an orange to red, and now we're at a bluish range. We still need to go a little bit. It's still not soldered fully. And I think now it's switching over to green. What the hell? This is weird. Yeah, now we're at a yellow range of color. Interesting. Again, I'm not sure if this is some sort of mechanism to tell if you solder on the correct temperature or not. I have never seen that. It is literally changing color on the surface while you do solder it. I mean, if I'm not mistaken, it's a copper package. So I assume with having copper, it changes color depending on the temperature it does have. But well, who am I? Just some idiot trying to solder some stuff here on the internet. I think that should be good now. So now let's just try to cool it off. So currently we're at a white, shiny color thingy of the ASIC. That's some wild stuff here. Again, I've never soldered such an ASIC chip, so I don't fully know. And the thing is, yeah, we need to wait for it to cool down. Then I need to apply a new heatsink and test it out. Because the idea with this board right here is something was broken. And initially we saw the broken part was the ASIC. So I switched it over to this ASIC. I don't know if this ASIC is fully working or not, if I soldered correctly or not, but this is the way of how you do it. So what I'm trying to do now is I will give it a little bit of time. I will wait for it to cool down, and then I'll see if it works. If it doesn't, now you do have a little bit of the information of how to change an ASIC chip, because that's the way on how you do it. Cleaning it up, applying new soldering paste, checking out a new ASIC, and soldering the ASIC on it. That's the way how you do it. So yeah, let's see if that works and if any other components produce issues. Because the previous ASIC was damaged and therefore there was some overcurrent happening. And yeah, you can clearly tell it got hot here. The U6 component here, you see that there. This is in LDO. Because of the old ASIC being broken, there was a short happening. And I replaced 2 of these U6 component LDOs until I figured, frick, the ASIC is dead. I need to replace the ASIC. So we'll see. I'm gonna be right back in just a second. All right, it's probably half an hour later. I got it, it's working. So usually I tell you guys never ever use this heatsink, especially with a gamma. This is just for testing purposes. What I was doing is I was trying to get this ASIC working, but in the end I figured, well, the chip itself is a little bit doomed, and I think this one here is it. It still does have a gold shiny-ish looking, but I was scratching over it, so I believe that's the reason why I was not seeing it. It was not recognized. And if you take a look on the back side, it's really junky and we have still lots of golden components. So I was cleaning the entire board. I was cleaning it. I was using my solder wick here, desoldering wick, I'm sorry. And I was using lots of isopropyl alcohol, and I was actually cleaning the whole section, reapplying new paste. This one here is also getting really empty. Yeah, I was doing that, and I used another one. I only had 5 and I needed 2 to get it working. So this right here was the issue, and this one is working. If we plug it in, it should boot up. Here we go, connecting to my Wi-Fi, and then the Bitaxe logo shines. And the next thing that should happen is it should go over. Yeah, it's connected to public pool, and it does have a IP address and the hash rate. Right after boot, we're sitting at random numbers here. So what I will do now is I will attach a proper heatsink. I will use this one right here, and then I can do some testing. Awesome. So this is working, and this is showing you how to actually solder on a BM1362 PM. This is the copper version, this one right here. And in the next video, which you should definitely not miss, will I try to figure out what is the exact difference when it comes to thermal performance between the PM, the BB, the BM, the AA, whatever I do have. I should have 3 different models laying around and I will test it. So that's going to be for the next video. Till then, I thank everybody for tuning in, for joining in. It works. We got a destroyed board and repaired it. Awesome.